Oh, you have to warn the students, it's kind of blinding up here. Students, be prepared for a lot of lights when you come up here. This is the third annual Energy Challenge sponsored by Electric International at the NECA convention. And the numbers keep growing each year, and thank you for coming and participating. This is a year-long process where the universities submit extensive proposals. They're reviewed by a group of judges. Those proposals are rated, narrowed down to 3, and then the 3 finalists come to this meeting. And then we also have a poster contest for the schools that come here but aren't involved as the 3 finalists. And they'll be at the Electric International meeting tomorrow afternoon up on this floor, so you can review the posters and what the other projects did. The 3 schools involved are University of Washington, Youngstown State University, and Milwaukee School of Engineering. We have a panel of judges here that have volunteered their time, and I'd like to introduce the judges. Maybe you can just kind of wave, and I'll tell where your company is. We've got John Hillick from Ferndale, right over here. Cassie Quaintance, Schneider Electric, right here. Jeff Thiede from Oregon Electric and Capital Electric Construction. Busy guy. Where's Jeff? Is he here? Okay. And Tim McBride from Southern Contracting. Is Tim back yet? Oh, okay. Tim. You wouldn't believe the lights up here. They're really intense. I should have worn sunglasses. Steve Watts, CSI. Is Steve here? No? Can't see him. Okay. Jim Conlow from Spurg Electric. Thanks, Jim. And Jerry Hayes, United Electric. Okay, thanks, Jerry. Adam Rood, is Adam Rood here? Okay, oh, hi, Adam. There. Is Dennis, did he make it? No, okay, he's not here. And Eduardo Mariscal from our international representative from Monterrey, I'm sorry, Mexico. And so we've got 11 judges, and they've got their scoring sheets in front of them. The judges can ask questions. Until the school cannot stay in the room until after you've given your presentation. So the first presentation is the University of Washington, and then we're going to ask Youngstown State and Milwaukee School of Engineering to leave at this point, unless they're not in here yet. Okay, they're gone? Okay. Okay, so the first group I'd like to introduce is the University of Washington. They're right here.
Good afternoon. My name is Aaron Yamasaki, and I'm a project manager at Montlake Energy Solutions. The project we are proposing today is a green energy retrofit on Haggett Hall, a dormitory on the University of Washington campus. Haggett Hall was constructed in 1963 and houses approximately 800 students each year. Haggett Hall what interested us about Haggett Hall was the fact that not too many changes have been made since its construction. We see this as an excellent opportunity to introduce new and innovative technologies that will greatly improve the energy performance of the building. Our project team consists of myself, Aaron Yamasaki, Ryan Hunter, lighting design, Matt Nugent, alternative energy, and Jay Danner, MEP and alternative energy analysis, Cyrus Naimi, financial coordinator, and Brian Taylor, lead engineer. On our initial review of Haggett Hall, we noticed a few points of interest within the building. We noticed that there was insufficient lighting within stairwells and hallways. The HVAC system was a steam-based system, and it utilizes the original units installed in 1963. In addition, the concrete panel and single-pane glass window exterior envelope provides poor thermal insulation for the building. We also wanted to make a point that the north-south orientation of the building faces provide a good amount of solar access. Our project team identified 4 design goals for this project. 1, lighting efficiency, to improve lighting efficiency within the building. 2, to introduce an alternative energy source on site. 3, to make sure every system we install is a complementary system that works with one another to improve energy performance within the building. And 4, to educate students and encourage them to become energy managers. Now Ryan will speak to lighting.
Upon our initial examination of the building, we found that all the lighting fixtures in Haggett Hall were upgraded to fluorescent light fixtures since its original construction. So we found that there wasn't a lot of opportunity to change the lighting sources. So we focused mostly on controls in our proposal. However, we did look at LED lighting, but due to their high initial cost, we found it not feasible on this project. We also noticed that there was a lack of natural lighting in the individual dorm rooms because of the odd-shaped rooms within Haggett Hall. In the parking garage, common corridors, and stairwells, these lights have to be on 24 hours a day for egress reasons. So we chose to upgrade these lighting fixtures to 2-way fixtures that will have minimum egress lighting mode and then have a motion sensor that will detect motion and turn on another lamp when that is required. We'll also be retrofitting PV cells to the exterior of the building. Currently these lights are on 24 hours a day. We'll also be putting these on interior lighting as well. There are a few common rooms that have large bay windows, and we'll find a good energy gain there. We'll also be adding motion controls in the bathrooms, the kitchenettes, and other miscellaneous storage rooms, as well as in the closets. To solve our problems with natural light in the dorm rooms, we'll be adding energy efficient windows. We'll have an operable opaque window on the opposite side of the current window now. In the end, we'll be saving about 33% of our annual energy bill and have a payback period of 3.5 years. Now Matt Nugent will talk about alternative energy generation.
When we looked to implement an alternative energy system, we reviewed both photovoltaic as well as wind energy systems. Unfortunately, due to the low average wind speed in Seattle, we determined wind to be an unviable option and have proceeded with a PV system. We reviewed many design characteristics for material selections, including inverter operation, aesthetics, string sizing, as well as solar access and shading. And one of our initial concerns was due to the orientation of the towers and the proximity, would there be enough solar access on the southern face of the north tower. To address this, we conducted a solar access study and determined an 89% solar access rate on the southern face. We also reviewed implement of panels on the rooftop space. However, due to the tall parapet as well as the high congestion on the roof, we determined that there'd be too much shading instead of installed their inverters at this location. For our inverter selection, we selected 2 Selectra PVI 60 kilowatt inverters to handle the absolute maximum kilowatts that our panel array could theoretically produce. For panel selection, we selected SunPower's E19 320 panels for their high efficiency as well as their aesthetic appeal. and as such a visible addition to the dormitory, aesthetics was a key component in this material selection. As you can see here, we'll be implementing the panels on both the southern faces of the towers, and the green highlights the precast panels to where the panels will be placed. Due to the hexagonal orientation of the rooms, the panel installation will not interfere with window operations. During the payback period, this system will pay for itself in 12.4 years with an annual energy generation of 106,000 kilowatts and an annual electrical savings of $26,400. Jay will now speak to energy usage.
We looked into multiple different options to completely revamp the current HVA system at Haggett Hall, which, as Aaron stated earlier, is a steam system. To do this, we looked into both a ProFlow system and a sewage heating system. We deemed both of these unviable for this project because of the age of the building. So we decided to try to make the steam system in the building as efficient as possible. To do this, we're going to utilize variable frequency drives on this project. The VFDs will provide energy to the system when loads are high in the building, and it will reduce this flow when, when the energy usage is low. This will improve our system efficiency to up to 95% and will provide us with less than a year payback period for this project, which is ideal. As Aaron mentioned earlier, the envelope of the building is a major concern, and we looked at two items to combat this. One is aluminum cladding on the building, and the other being to use energy-efficient double pane windows. We decided not to do the aluminum cladding because it wouldn't provide a positive return on investments, so we went with the double pane windows. The double pane windows that we selected have a low E film, which deflects infrared radiation back in the room, keeping it warmer, and also the double pane window creates a thermal break, keeping energy in the room and not letting it escape through the envelope. Looking now at the schedule, we were confined by the University of Washington and their needs in this project. We are a university at the University of Washington that has classes all 4 quarters, including summer. And so since less students will be around during the summer quarter, we decided to do our project during this period. There will be students and faculty and some guests to the university occupying Haggett Hall at the time. So because of this, safety is a #1 concern for our company, as it is on all jobs, but especially because this is a college university. To fit our project into the compressed time frame, we decided to use a 4-phase schedule, starting with our lighting retrofit, moving to windows, our variable frequency drives, and finally our PV system. Now Cyrus will speak to our financial plan.
We've estimated our total project cost to be roughly $1.6 million. Our photovoltaic system contributes to 1/3 of these costs, and the energy usage retrofit, which includes the windows and variable frequency drives, contributes to just over 1/3. Also, due to the tight schedule and partial occupancy during construction, we feel it is reasonable to include an 8% fee. We've selected Washington Windows and Doors to install the windows on this project, and due to several past experiences with them have been very successful. We know they perform work at the highest of quality. Therefore, we feel there's little risk associated with working with them again. We were able to produce roughly $315,000 in incentives and rebates. These are both on the federal and state level. Seattle City Light offers generous savings opportunities with rebates based on the amount of energy savings due to fixture replacement, additional controls, and glazing replacement. Another source of our funding was the Bonneville Environmental Foundation, which covers 33% of our PV system costs. Combining these savings with our annual energy savings, we expect a payback period of 9 years. And now Brian will speak to lead.
We recommend multiple options for decreasing the energy demand and increasing the sustainability of Haggett Hall. All the retrofits included within our proposal exceed both local and national standards. As such, the Housing and Food Services would earn a total of 34 points under the LEED Existing Buildings 3.0 guidelines. Should the Housing and Food Services decide to pursue LEED certification for their facility, we have provided to them a breakdown of each credit, calculations for each credit, and a scorecard to provide a summary overview. Ultimately, our proposal would decrease energy usage by 47% and increase on-site energy production to nearly 18%. Should the scope of the project extend beyond electrical systems and into mechanical systems, the project team has identified 7 additional points under the water efficiency credit. These additional points would allow the Housing and Food Services to earn certification for their facility. In terms of student awareness, Montlake Energy Solutions' primary goal was to develop a multifaceted approach which would transform the tenants of Haggett Hall from passive consumers into active managers of energy. First, creation of graphics and posters would focus the awareness of the tenants towards energy conservation. Second, participation in an incentivized competition known as Campus Conservation Nationals would allow the tenants to actively participate in energy conservation. And lastly, being involved in a club on campus known as the Student Green Building Council will provide a platform for the tenants to become leaders within the green community. Our goal was to create enough avenues so that each student can find one that suits them. Aaron will now speak to client and NECA interaction.
Our interaction with the University of Washington's Housing and Food Services was crucial in developing a plan custom tailored to the university's needs. We spoke with a number of groups on campus, including the HFS's Sustainability Board, a number of sustainable student groups, as well as plant and facility management personnel to really capture the vision of the university and incorporate it into our proposal. We'd also like to thank the Puget Sound NECA chapter and its contractors for their continued support throughout this process of development. Our team strongly believes that the Haggett Hall Green Energy Retrofit is a perfect fit for our company. We know that the University of Washington is planning a number of similar retrofits on campus, and we think this is a great opportunity for us to get our foot in the door with the university and establish ourselves as a reputable contractor. With your permission, we'd love to get started on this project right away. Thank you, and we will answer any questions you have.
Nice job, you guys. It's all of them. Okay. I'm curious to hear from you in your customer interaction. What was their tolerance of a 9-year payback? And does that fit their needs? What type of discussion did you have with them on that?
Jay, could you please answer this?
We met with, as Aaron said, many HFS representatives, which is who is in charge of planning everything that goes on with renovating a building at the University of Washington. And their expectancy is to renovate this building rather than build a new one. So a 9-year payback period definitely fit in to their needs as they want to keep this building around for years to come on UW's campus. Thank you.
Can you put that slide back up there on the financing, on the estimate? I'd like to see that. And then, as I heard during your presentation, you were talking about you had a 8% that you felt you were owed. I'd like to know how you came up with that.
Cyrus?
Well, basically what we thought. So, as I said, with the risk that that we take on, sorry, collect my thoughts here.
It's about making money.
Right. I'm trying to remember my speech here. So we feel that this risk is reasonable, basically because we need to make some kind of profit on this, but also cover any kind of risk we might take. And like I said, we have a tight schedule. There's partial occupancy. We're working very fast, and we're trying to be efficient. So we feel this covered any kind of risk that we might hit in the future. But we have that pretty much covered with the schedule as well. But we'd like to make this project somewhat profitable, but also keep it competitive.
I got it. I got what you're saying. But why the 8%?
Well, we just, upon the original assessment of it, we were originally in charge or assess a 5% fee. But upon looking at the schedule and the kind of work that we're doing, installing the photovoltaics is a little new to us. So we decided to bump it up a little bit more just to I guess, cover it on our end.
Make a buck. Say make a buck.
What, make a buck a little
Make
bit.
a buck,
Just,
all right.
well, I mean, there's a little profit involved, obviously, but we feel it's a little bit above what industry standard would be, but because it's a little different with us, with the photovoltaic system, we figured it's reasonable.
Thank you.
Thank you.
So is this mic on?
Yes.
I think you'd find most people out here think your fee's too low. Not too high. Yeah.
Well,
We are for profit out here. So the question I have is, in a world of limited budgets like we have right now, it's very difficult to come up with this money for the university right now. If it was your money, which of these systems would you choose? Let's say we can only do half of them. Which would you think that would be the best to do right now?
well, we identified payback periods for each of our systems, and if we really had to slash down and choose the most bang for our buck, we'd definitely go with the VFDs, seeing that they had under a year payback period and provided a lot of energy savings.
Got a question. In your calculations with the incentives, does that mean the project has to be underway, or does it have to be completed by the end of the year? And what are the expiration of those incentives?
We spoke with the Bonneville Electric Company, the Bonneville Foundation, as well as Seattle City Light, and these incentives are instant payback incentives, so once the project is underway, they will come into effect.
Thank you.
You're welcome.
I've got two questions. First one, how did you calculate the savings? Calculating kilowatt hours at a certain rate and then calculating another rate. Why the difference? That's the first question.
I'm sorry, could you repeat that?
I mean, on your calculations, on your
Uh-huh.
you use 25 cents and you use 6 cents,
Ah.
one way and the other.
The reasoning behind that is the 6 cents is Seattle's energy rate, and this presentation was calculated based off of a 25-cent base fee to equalize the city differences between our schools.
Which one are you going to work on? I
For
mean,
the-
which one are you going to apply?
For this project, we have applied the 25-cent.
And the second question is, I found your little poster
Mhm.
with a switch, with a light switch,
Mhm.
very attractive. What was the feedback of your school? I mean, what was the reaction of the rest of the students?
We showed that picture to a number of the student groups during our meetings, and it was a very positive response. They appreciated the use of humor within the poster.
You guys thanked your local NECA chapter for their involvement in assisting you putting this together. Can you expand a little bit on how that process went and how you guys met with them and how much input they had in the process?
Absolutely. Tommy Key at Puget Sound NECA chapter introduced us to a number of contractors to help us along our path and inquiring on topics that we needed more a deeper understanding of, such as the PV panels system. Matt was able to meet with specialists on this topic and really help him to understand what it takes to develop a system and produce what you saw on the project.
I just have one final question. As you guys stand up there, number 3, I didn't get your name. Jake? Okay, thank you. That was my question.
Thank you very much.
Thank you, University of Washington. Good job. That was the most intense questioning we've had in 3 years. So the judges are getting into this, I could see. Okay, the next school is, you ready on there? Okay. Next school is Youngstown State University, and they're on their way up right now. You know, when you're sitting here, the kids are really well lit up here, but when you're standing here, it's like you're in an interrogation room, and the lights are just right on you right here. So.
Good afternoon. My name is Justin Hussein-Jad, and I'm proud to present you the Youngstown State University Energy Upgrade for Cafaro House for the 2011 NECA Electric International Green Energy Challenge. But first, let me introduce you to the Penguin Power team. Like I said, my name is Justin Hussein-Jad. I served as project manager as well as a lead coordinator. Next, we had Jason Nutt, who is our lighting systems designer. We had Ethan Parks, who's our financial planner. We had Michael Sammartino, who is our power distribution analyst. Jarrett Scacchetti, our alternative energy designer, and David Wright, our schematic estimator. Youngstown State University is a campus of 15,000 students divided among 7 different colleges. Across the 140 acres, Youngstown State is mainly a commuter campus, so therefore there's not a lot of residence halls. But one of the 6 on campus is Cafaro House. And as you can see from the picture, it is a 4-story building comprised of 2, 4, and 18-person suites. And also, there is academic spaces for offices, classrooms, as well as computer labs. The building was constructed in 1994 and opened for residents in 1995. And since the building was only 17 years old, it was a good opportunity for the team to apply green energy applications to the building. After talking with Youngstown State, we developed several goals to keep in mind throughout the proposal. First of which, to promote green energy in the campus community. Next, reduce overall energy usage. Also, big factor was to produce on-site renewable energy, as well as return on investment is very important for the campus. Before moving on to the actual proposal, the team had to assess the initial building to figure out what the different types of systems were in the building. First, for the lighting system, there are occupancy sensors incorporated into all spaces except the resident rooms. Also, very importantly, relatively efficient fixtures, but they were outdated with T8 lamps. And finally, there were very inconsistent lighting levels throughout the building, as Jason will tell you later. Next, for the power distribution system, like I said, the building's only 17 years old, so we determined that it was adequate for the future demands and upgrades of the facility. And finally, the mechanical systems. The equipment, which includes motors, elevators, chillers, and etc., was relatively inefficient due to the fact they did not incorporate VFDs, which Mike will talk to you about later. But right now, I'm going to bring up Jason not to talk to you about our lighting system design.
In 2006, Johnson Controls was contracted with YCO to do an energy efficiency upgrade. So what we had to do is we had to reflect upon that. They were signed with a 10-year contract, and they mostly concentrated on the HVAC controls. And one of the areas that they touched on was lighting. With the lighting, what they did was they did a direct replacement with the lamps. They switched out the old T12 lamps in the linear fluorescence with T8 lamps. And they switched out the 26-watt compact fluorescence in the downlights with 13-watt compact fluorescence. One of the options that we did have was to put occupancy sensors in all of the dorm rooms. However, when we did the cost estimate, it didn't have a really good return of investment. So we tried to keep in mind what was best for the owner. In the typical dorm rooms, the existing layout right now has two 2x4 or 1x4 linear fluorescents with two T8 lamps that were put in by Johnson Controls. We concentrated on 3 areas: dorm rooms, common areas, and the corridors. In the corridors, there was really inefficient fixtures, and really, it wasn't so much the lamps that were inefficient, it was the fixtures. It was the fixtures themselves because they were outdated. There was really uneven lighting levels as well. We went through with a digital light meter and we did some calculations in our initial field survey. And what we found was that within a 5-foot span, there was lighting levels of spanning from 100-foot candles to 5-foot candles. And it's pretty big in, impact in the hallway. So if you're walking through, you're going from blinding light to really low light levels. What we tried to do in our presentation and our proposal was even out those lighting levels to make it a little bit more architecturally presentable so that the owner, has that pleasing visual. In the corridors, what we proposed doing a direct replacement with the lamps on the downlights with an LED lamp. Let's see if I can get this to go here. In the dorm rooms, what we did was a direct replacement with the 1x4 linear fluorescence. We proposed that we would put in a single T5HO lamp fixture, which is by focal point. It's called the focal point equation. It's really architecturally pleasing. It's nice. It's easy on the eyes, and it's also environmentally aware fixture. So we're reducing the number of lamps. We're making it look a little bit better, and it's going to really be better for everybody. In the corridors where we were replacing the lamps with the LED fixtures, the areas that had 100-foot candles, there was 2x4 linear fluorescent fixtures in there. And what we did in our proposal was replace them with the same LED lamp that also came with a housing, and that was by Lithonia. It's called the Lithonia Reality. So we were really lucky that there was an option for us to have a retrofit for an LED fixture and also have a housing that could match the existing downlights in there. Really helped out our proposal. Lastly, one area I'd like to talk about is Mercury Content. It's not an area that is really spoken of or researched a lot. It's in LEED 3.0. It wasn't a requirement for our project, but I thought it would be really good to speak about. As you know, mercury is a very harmful chemical, and it affects our wildlife and our fish preserves. So I went through the existing lighting layout, and I calculated the mercury layout of the Mercury Content calculations. And I also calculated the mercury content that would be proposed with our proposed lighting system. In the existing system, we calculated 32.22 picograms per lumen hour. It's a pretty hefty amount of mercury, and what we managed to do by reducing the number of lamps in each of the dorm rooms and replacing them with that focal point equation fixture, which has a very low picograms per lumen hour content, or mercury content, and we also replaced the downlights in the corridor with LED fixtures, we managed to reduce it by almost 2/3. So I thought that was a very great thing that we could do. We could affect customer costs with maintenance purposes because They only need to have one lamp for replacement with the fixtures, and we could also make an impact with our environment. So I'd like to turn it over here to Mike Sammartino, and he's going to talk about the distribution.
Hi, I'm Mike Sammartino, and I'm going to be going over the distribution system upgrade that the Pane 1 power team is proposing. Now, as Justin said, Cafaro was built in 1994, which as a structure isn't that old, but technology-wise, 17, almost 18 years is way behind the power curve for what we have now. Moore's Law states that every 2 years, processing power is going to approximately double. So 18 years later, we have about 9 times more processing power that we could use in these VFDs to do the digital signal processing that needs to be done to save energy. The chiller from 1994 has over 75,000 starts on it already, which is a substantial load for an electric motor to take. The electric motors currently do not have any means to control the speed except an on and off switch and the frequency of the power grid. And the equipment should be digital and networked. Like I said, we have 9 times more processing power today, and YSU already has an existing Ethernet network and Wi-Fi that we could take to our advantage. All right, the variable frequency drives we want to incorporate into the existing mechanical equipment. We're only going to propose them for our 3-phase equipment, not our single-phase equipment, because the payback on the single-phase wouldn't be justifiable to spend the money. The payback would take too long. And also the 3-phase equipment, some of them are 20 to 30 full load amps, whereas a single-phase, we're talking 1 amp at most. The VFDs are going to reduce the power consumption because of the affinity laws. The shaft speed isn't proportional to the power required. It's actually the cube of the power required. So if we arbitrarily choose to run our motors at 80%, we're going to save 50% of the power right there. And in Youngstown, with the weather changing so much, we don't need 100% on all the time. We could do 80% on, and it'll just take a little bit longer to get to the correct heat, but if you're saving half the energy, why not take that to our advantage? The VFDs also increase the lifespan of the equipment. That's because the motors have the inductive surge. As soon as you turn the switch on, it's going to immediately try to go to the full torque of the motor. That's just a property the inductors have, and it could draw up to 10 times the rated amount of current, which is going to kill the armature windings because it's the real thin wire. And the VFDs also improve the power factor. Even though Youngstown State isn't penalized for having a bad power factor, it'll be more efficient for us to do it that way. Now, our biggest goal was to make the students aware of the energy they're using. So we're proposing to put these sub-metering systems throughout the campus. What they're going to do is allow a real-time view of the power being used. At first, we want to put one in each building, which will also help maintenance out. That way, if they could see if there's maybe a relay stuck open or something that's drawing a substantial amount of energy, and they could just, they'll get an email or whatever, they'll be dispatched to that area to fix it. But in the end, we would like one per every dorm room. That way the students can see in real time. They could look on their iPhones or iPads, whatever they have, and say, hey, I'm running the microwave, I leave the lights on, I got the air conditioning at 63 degrees. They could see that, wow, I'm really wasting this much power, and then they could fix it. Because if you know what you're doing, it's easier to fix it. But if you're clueless, then there's no way you're going to fix it. And that's how we want to get our students directly involved in the green practices, because they're the majority of our campus. So I'm going to pass it over to Jarrett Scischetti right now. He's going to talk about the alternative energy design.
Hello, I'm Jarrett Scischetti, and I'll be discussing the alternative energy design part of our proposal. Our proposal incorporates both the use of wind and solar energy. Now, the design of this was unique due to the limiting factors that Cafaro House poses. The pitched roof and courtyard area really impacted our design and made us think outside of the box to both produce a design that is effective in promoting awareness, but also efficient in creating energy. The pitched roof affected us because we could not install a large solar panel array on the roof, as traditionally you will see with most alternative energy designs. The courtyard area outlined in red represents the area that is used on a daily basis by the students of Cafaro House for recreational use, and we do not want to take any area away from them. That's not what we want. We want to give to them, not take. Now, for the winds, we used a vertical axis wind turbine over a traditional horizontal axis wind turbine due to the safety fall radius that wind turbines require. Because of the safety fall radius zone of 150 to 200% of the wind turbine height plus the blade, it was hard to comply by due to the limiting property size and urban location of Cafaro House. we determined the VOT was, or the helical wind turbine was the best solution. Additionally, by using a helical wind turbine, we can remove the negative connotation that the community may have with wind energy, because most people, when they say or hear wind energy, they think of like a windmill, the traditional horizontal axis. By showing that there's more than one option to wind energy, we really promote green awareness by showing what's available and maybe inspire them to install a wind energy system in their own homes. Lastly, our wind turbine has a low cut-in velocity to account for regional climate. Now, the location of all the equipment was specifically placed to have the maximum promotion of energy awareness to not only to the students, but to the community as well. If you look on the map in the legend, the blue circles out in front represent the 2 helical wind turbines. The 3 green on the roof represent the 2x4 framed solar panel arrays mounted on the roof. Now, the 2 orange circles represent the ground-mounted 4x4 framed solar panel array using a locally manufactured solar flex rack. Now, we're double dipping in green energy savings by using a locally manufactured product by reducing on the carbon emissions that are produced by the transportation of goods. So we're really being green by thinking outside of the box and covering all the areas possible. Now, by having the equipment on the ground and in front by the intersection, you really promote that green energy to the community because there's thousands of people that drive by the intersection on a daily basis. So they really can see that YSU has gone green and maybe be inspired themselves to see what alternative options they have for their own homes. Now, the main benefactor to the students for having all the equipment on the ground is that it can be used as an educational tool that is readily accessible. YSU, as Justin said, installed a solar panel array on top of Mosier, the engineering building. But to get to that, you have to climb the stairs and maybe get special access. By having it on the ground, you can just walk up to it and have at-hand ease to it. So it's really accessible to use as an educational tool. For the distribution, we're going to be using a Sunny Boy inverter rated at 8 kilowatts to tie in the 56 solar panels and, sorry. What? Yeah, okay. We'll be using the Sunny Boy inverter to tie in the solar panels to tie them into the grid. The helical wind turbines have an inverting kit automatically incorporated into them, so they will not be needed that. For the storage, all energy created will be consumed real time, therefore no storage is needed. I will be passing it off to Dave Wright to talk about the schematic estimate and schedule.
Okay, the total project period is going to be roughly 116 days. Out of these 116 days, we have figured in time for not only your product lead time, your product submittals, which is to ensure that you guys are happy with the product that we are proposing to you guys, as well as any punch list items at the end, in case there's anything that is missed or overlooked. Now, we try to minimize the interference with the everyday operations of the facility by doing the most intrusive thing, which would be a lighting retrofit during the summertime when the students aren't in the dormitories. All the projects will be taking place simultaneously, and the dormitory will remain fully operational throughout the whole process. Okay, the overall cost. Now, for a lighting retrofit, it's just under $90,000, and that's all your new light fixtures. The distribution upgrade, which includes the sub-metering for the firehouse, as well as the variable frequency drives, is $38,175, and the estimated alternative energy cost for the project is $97,520. Now, we broke this down into 2 proposals. The base proposal is just your distribution upgrades as well as your alternative energy. For that, what you get out of that is a 25% faster return on your initial investment. Also, you're going to promote the green awareness on campus because the students are going to be coming in and are going to see those solar arrays, they're going to see those wind turbines, and everybody that's driving by is going to see those. And also, you're going to create a great example of how you could take a new facility such as this one and really make it even more energy efficient. I mean, most facilities you see doing this are ones that are older. This is something that's new. This tells everybody that, hey, there's always room for improvement. Now, if you take the total proposal, which comes in at $225,000, you get all 3 systems. What you get out of this, of course, is your additional kilowatt-hour savings. The payback period is a little bit longer, which Ethan will discuss with you in here in a little bit. but you get the environmental impact, which Jason talked about with the mercury content reduction. That's the big thing. We kind of want to go outside the box a little bit by coupling in the newer facility and a different type of approach, because we don't really see this in our area. Everybody's looking at dollars and cents. We kept that in mind also, but we really wanted to promote the whole thing, the whole total package. Now, I'm going to let Ethan talk to you a little bit here about our financing plan.
Now, as you can see here, with the total systems cost between the lighting incentives and the VFDs, the total project cost is just a little over $225,000. Now, right now through Ohio Edison, they are giving out major incentives for companies that are wanting to go green. So between the lighting and power incentives, YSU can get just a little over $11,000. So that would adjust the total project cost to being just a little over $214,000. Now, for the annual kilowatt per hour savings, between the lighting upgrades, the VFDs, the on-site energy generation between the wind and solar, the total kilowatt hour savings was just a little over $319,000. Now, for Ralph Marone, according to he's the building administrator, he says that YSU only pays a little over 6 cents per kilowatt hour. So that means that the total yearly savings is going to be just a little over $19,000. So the total payback period would be a little over 11. Now this graph here shows, oh geez. Go back. Okay, now this graph here shows that if you were to do each section individually. Now as you can see, the lighting here is just a little over 24 years. Distribution is just a little over 3. Alternate energy is a little over 17. Now the total proposal is if you were to do the lighting, the distribution, and alternate energy all together. Now the base proposal, which is just a little over 8, is if you were just to do the distribution and alternate energy. I'm going to pass it back over to Justin.
Okay, now that you've heard our entire design proposal, the last aspect that we had to incorporate was LEED for Existing Buildings version 2.0. Now, as a campus, Youngstown State is already very familiar with the LEED process. In fact, the newly constructed Williamson College of Business is LEED Gold certified. So after talking with Youngstown State, they would also like to pursue LEED Gold certification on this project. To achieve that, we would need 48 out of 85 possible points. If you look at the various categories, sustainable sites, water efficiency, energy and atmosphere, materials and resources, environmental and air quality, and innovation and design, we get a total of 53 out of 85 points, thus achieving the desired gold certification. Although all these categories incorporate into our design, the major focus was energy and atmosphere as well as innovation and design process. As an overview, let me discuss the goals that we've completed. First, reduce energy usage. The team has incorporated that via the energy efficient lighting retrofit and VFD installation. Second, produce on-site renewable energy. As Jarrett said, we have wind turbines and solar panels in prominent locations at the facility. This incorporates into the next goal, which is to promote green energy in the campus community. These forms of alternative energy are in prominent locations. They're very visible to not only the community, the faculty, and the staff, and it's going to be used as a teaching tool. Just like Jarrett said, like at Mosier Hall in the College of STEM, there's solar panels on top, so the electrical engineers can study them in their actual environment. So this will be used as a teaching tool for the campus. And finally, return on investment was a big focus for the team. Not only did we provide you one bid, we provide you two ideas. Do you want to do the total package, which is 11 years, or the base bid, which will get you savings, but only take a return on investment of 8 years? As a student chapter, the Youngstown State NECA student chapter is very involved in the green energy movement in the community. First of which, you can see an article in the local newspaper, The Vindicator, that's detailing the team's initial site assessment of Cafaro House. Next, in the bottom right, you can see a picture of several members of the team at the Warren JTC Training Center in our local area after they've taken a tour of the facility as well as learned different forms of alternative energy. And finally, a big component of this proposal was to get feedback from the faculty, staff, and students at Youngstown State University as to what their interpretation of green energy means. So to accomplish this, the team decided to pursue what's called the Green Initiative. We sent out a mass email to every person on the campus of Youngstown State University and wanted their feedback. What is your interpretation of green? We have got approximately 70 different ideas, and we actually incorporated the best ones into the final proposal. So now that you've heard our entire proposal, as well as our LEED recommendations, and how we are as a NECA student chapter, I would like to open up to any questions that you may have. you.
I'd like to hear more. You mentioned in your energy plan about sub-metering and how to involve students in understanding when they're using more or less energy. But it wasn't clear to me, is this part of the proposal, putting these meters in every room, as well as the interface? You know, you talked about being able to show that data. It's a nice idea, but is that actually part of this proposal?
I'll let Mike answer that question.
It was factored into the actual dollar amount for the proposal. For as far as viewing the data, there's Ethernet ports on them, which can be interfaced very nicely into YSU's already existing internet system. Also on the meter is a 7-segment displays that show real time what your output is. Like I said, the biggest thing with the sub-metering is students can view how much energy they're using, because if you ask 99.9% students at YSU, they're going to be clueless as to how much energy they're using. And really relative to, I mean, you look at a 13-watt light bulb, and then you look at the 30 full load amp chiller, really the impact isn't that great, but it could be when there's 15,000 students that are, you know, turning off the lights, not putting their air conditioning on 63 degrees. If that chiller's not running with the variable frequency drive, it could just shut it down 10%, use only what it needs. Did I answer your question well enough?
Any other questions?
Tell us a little bit about your interaction with the local electrical contractors NECA chapter.
The local NECA chapter actually helped us out a lot in terms of especially the presentation as well as the preparation of this proposal. Just one example, we actually, we're in Youngstown State, which is in Northeast Ohio. We took a trip up to Toledo to present at a regional conference to local contractors at a energy forum up there. So not only helped us in the presentation, they also helped us get feedback. What is actually feasible in terms of the design, and what are we looking at for return on investment, and just in general suggestions.
I see that you also included a demolition schedule. With how did you come to that?
I think it's a question for Dave.
Oh yes, we didn't. The demolition is going to be included in part of the retrofit. The only demolition that's going to occur really is going to be the removal of the existing fixtures. There was time in there for lead time for the new products, for the delivery, as well as the submittal process for approval of the owner. But as far as demolition, that could take place as the fixtures are being swapped out themselves. Is there anything else?
Thanks.
Quick question for you. On the turbines you guys are proposing to put up, what kind of wind analysis did you guys do to come up with the type of turbine you're proposing?
That's a good question for Jarrett.
Last year, we accessed data from one of the state websites that gives the average wind speed for the area. We used the same data from last year to accommodate for this year, since both of the facilities are in Youngstown. The wind turbines are the low cut-in velocity to account for days where it's not as windy. Does that answer your question?
You got a question?
Yes.
Do you see any impacts to your pricing if the project was delayed for 6 months?
Dave, would you like to answer?
Well, I think one thing you definitely have to account for is if the local labor rates went up. So yeah, there would be somewhat of an impact there. Generally, things like your fixtures and things of that nature, you usually don't incur any kind of increases in that factor, but I mean, it's possible.
Thank you.
I have one more for you. On the estimate you guys put together for this thing, you didn't have anything in there showing any type of overhead or profit that you guys are expected for this, or either that or I missed it, one of the two. Can you address that?
No, that wasn't directly on one of the slides. Basically, what we went off of was local prevailing wage rates. I used personally the AccuBid software, and I threw in there a generic markup of what what we would want to see out of it, which is around 15 to 20% on each system respectively. And the labor rates were, you know, your journeyman wiremen as well as your apprentices. We utilize some apprentice labor also.
Thank you.
Any other questions? All right, thanks.
Okay, is the next team in the room? Here we go, okay. Our final contestants are actually last year's winners. It's the Milwaukee School of Engineering.
Good afternoon, ladies and gentlemen. Xcel Electric is proud to announce the reinvention of our company as an energy service provider. Performing the energy audit on the Roy W. Johnston dormitory solidified our beliefs that we can improve our profits by becoming an industry leader in this market segment. But before we dive into the proposal, I'd like to introduce to you our team members, starting with Dylan Sandretto, lighting designer, Jessica Iverson, mechanical designer, Jessica Phillips, sustainability designer, Elise Pinkerton, renewable energy specialist, Brandon Jacobson, construction manager, and myself, Noelle Lehman, project manager. MSOE was founded in 1903 and since then has become a historical landmark located in the heart of downtown Milwaukee. It is currently situated on a 15-acre campus consisting of multiple aging buildings, one of which is the Roy W. Johnston Dormitory, or better known as RWJ. This is an 86,000 square foot building consisting with 12 floors with 20 rooms per floor. Approximately 420 students reside in this dormitory yearly. In January of 2010, MSOE issued an RFP for an energy audit to be performed on RWJ. Upon our initial site visit, it was apparent that minimum upgrades have been made to this 46-year-old building. Using such tools as the NECA Energy Efficiency Survey, ASHRAE standards, and Johnson Controls Metasys building automation system, we were able to accurately quantify the amount of energy being consumed in RWJ and therefore recommend various load reduction measures in lighting, motor controls, and through the installation of a photovoltaic system. Our largest energy savings was found to be in lighting.
We met with the school's maintenance engineers and toured the electrical and mechanical systems of RWJ. From their comments, we learned that the lighting system was in need of the most attention, as it has not been changed since 1965. There are currently 3 fixtures in each room, 1 overhead and 2 over each of the desks. They currently use the older T12 style fixtures with 92 watts per fixture. We also measured the lighting levels in the dorms and determined them to be overlit for their needs. Here's a current ceiling plan of RWJ. We studied the alternatives of LED, T5, and T8 fixtures and determined the most cost-effective solution was to replace the overhead fixtures with 64-watt T8 fixtures, replace the under cabinets with 18-watt T8 fixtures. That reduced the room's total electrical load down from 276 watts to 100 watts, a 64% reduction. We also found approximately 40 other locations, such as bathrooms and janitor closets, that frequently have their lights left on, and we recommend the installation of occupancy sensors in those areas. We used AGI 32 to model a typical MSOE dorm room and took our standards into effect. We determined the lighting levels to be sufficient compared to IES standards and also performed a daylighting analysis.
For this lighting retrofit, Excel estimates a total construction cost of $61,000. Because of this retrofit, MSOE is eligible to receive a Wisconsin Focus on Energy incentive, which would lower the final project cost to $59,000. MSOE will see annual savings of $44,000 and a rate of return of 75%. This will provide MSOE with an excellent payback period of less than 1.5 years. Using a unit price from RWJ's retrofit, we have found 7 other locations on campus that are in need of this upgrade. These 7 locations would provide us with a potential construction cost of just over $540,000. Our second highest energy savings proposal is in the mechanical systems.
We installed a building automation system on the building's electrical panels to help monitor electrical usage per floor. In doing this, we found that RWJ's power factor is currently 0.5. To correct this, we propose the installation of capacitor banks, which would help improve this power factor and eliminate the penalty they are currently being charged by We Energies. In addition, we surveyed the building's mechanical equipment and found that it has not been replaced nor upgraded since building construction in 1965. In addition, we performed an ASHRAE survey to gauge student comfort level in the dorms, and this survey, which we performed in the winter, found that the large majority of students were too warm. In fact, 49 of 50 students admitted to opening their windows in the winter. This means that a huge amount of energy, and thus money, is simply being lost through these windows to the outside air. To correct this, we took a look at the boiler system and found that currently it's being controlled on outside air temperature alone. This graph here, which has been used since building construction and is still in use today, shows the relationship between outside air temperature and boiler output temperature. This means that no matter how hot the dorms get, the boiler will continue to heat them as long as it is cold outside. To correct this, we propose that the temperature sensor be moved somewhere inside of the building. This would create additional wiring work and would allow the boiler to shut off or reduce its output once the building has reached a sufficient temperature. In addition, we propose the installation of air curtains at the building's entrances to help reduce the amount of energy lost as students come and go throughout the day. We performed a thermal image survey on the outside of the building to help pinpoint any areas of high envelope losses. In doing this, we found that the building's single pane windows have a very poor R value and are currently an area of high energy loss. To correct this, we propose they replace these with double pane windows with better thermal properties. In addition, we recommend the installation of a thermal preheat system to help reduce the load on the building's 2 hot water heaters. Our most beneficial upgrade to the building's mechanical system will be the installation of variable frequency drives on some of the building's largest motors. This includes 2 75 horsepower motors currently serving the building chiller. This chiller is sized to cool 6 floors of the building. However, currently it is only hooked up to cool the first floor. This means that it is incredibly oversized. To correct this, the VFDs would allow the speed of the pump motors to be reduced, thus reducing their power consumption. A pump motor has a cubic relationship between its speed and its power consumption, meaning that even if we can reduce the speed of these motors by a small amount, a large amount of energy can be saved.
Excel proposes that MSOE installs 6 VFDs for a total construction cost of $26,000. Less a Wisconsin Focus on Energy incentive and a WE Energy incentive, the final project cost is lowered to $17,000. MSOE will see an annual savings of $28,000 and a rate of return of 166%. This will provide MSOE with an amazing payback period of just over a half of a year. Our third energy savings proposal is in photovoltaics.
MSOE currently already has several sustainable sites on campus. These include a living roof on the Groman Museum, a 30 kW array on the roof of the campus center, and a solar reheat system on the roof of the other dormitory, MLH. As well, you can see a proposed location of a new 2 kW array, which will be in the parking lot adjacent to RWJ. The array will be housed on top of a carport structure that will also hold the panels and pipes for the solar reheat system, as well as a GE Watts charging station. We designed a utility interactive system in order to maximize value for MSOE. The photovoltaic array will be wired in parallel with an existing 208 volt panel in RWJ. The electricity generated by the PV system will be used to help offset additional single-phase loads, such as the car charging station. The main purpose of this structure was to be an educational tool that students and faculty would see as they walked around campus and that professors could use in their classes.
For our educational solar array, Excel proposes an overall construction cost of $19,000. Minus a Wisconsin Focus on Energy incentive and a Milwaukee Shine incentive, the final project cost is lowered to $14,000. Using the energy produced from the solar array and the profits from GE's Watt Station, MSOE will see an annual savings of $1,200 and a rate of return of just over 6%. This will provide MSOE with a payback period of 16 years.
MSOE would receive lead points for system-level metering provided by the use of the Metasys building automation system, which was installed with the help of Johnson Controls and Venture Electric. They would also receive lead points for the photovoltaic system in the parking lot, replacing the T12 fixtures in the dorm rooms, and upgrading the mechanical equipment as proposed. These upgrades would come to a total of 29 points, which is more than half of the points required for LEED certification. Additional upgrades and new policies in each of the LEED categories would combine for a total of 53 points, which would attain LEED Silver certification for the client.
Our overall estimate includes the lighting retrofit, the solar array, GE's Watt Station, and the 6 VFDs for a total project cost of just over $109,000. This takes in consideration that MSOE is a nonprofit organization and therefore all the material is tax exempt. Here's a quick Gantt chart showing that the lighting retrofit will consume the most time, but you can also see the 3 projects that we plan on completing during this retrofit. This will allow Excel to keep 6 local 494 journeymen working for just under 3 months. We have designed a retrofit schedule as to not interfere with MSOE's summer activities. This schedule is broken into 4 main phases, with each phase containing 3 floors as to minimize mobilization costs. The first phase will begin June 1st, with the following phase beginning June 21st, and the last 2 phases beginning July 8th and July 27th. We estimate an overall completion date of August 17th.
If MSOE moves forward with our recommendations, they'll be able to consume approximately 270,000 less kilowatt hours a year, amounting to an annual savings of just over $75,000 a year. As an energy service provider, we were able to recommend energy conservation through the installation of occupancy sensors and a student energy awareness program. energy efficiency through light fixture upgrades and the installation of VFDs, energy reliability with a capacitor bank and a short circuit analysis, and energy production with a photovoltaic system. As Brandon mentioned earlier, this comes to a total job cost of just over $109,000, with a healthy profit and overhead for Excel Electric of over $21,000, and a very favorable payback for MSOE of 1.5 years. As a design-build contractor, Excel Electric has the tools and knowledge to move forward in the energy service market. Not only can we improve our profit levels from 3 to 7%, but help our clients control their rising energy costs, along with becoming better stewards to the environment.
As students at MSOE, we have had the opportunity to experience many of the green projects on campus that seek to reduce the carbon footprint and increase environmental awareness. A few of these programs include the Recyclemania competition, the EPA Green Power Partnership, a recycling and compostable program, as well as a drink refill program. To engage students further, we proposed implementing a 2-tier energy awareness program called Reduce with Roscoe. The first tier of this program is focused on student contact and involvement, while the second tier is institutional, implementing energy awareness into the university's existing curriculum. Designed to complement Recyclemania, which is an annual competition MSOE currently participates in, Reduce with Roscoe will host an electricity conservation competition between the residents on each of the 12 floors in the RWJ dormitory. Students will be able to log into RWJ's Facebook page to monitor their floor's electrical consumption. Also included on this page will be a link where they can click to view the real-time data. This link will bring them to a website which is designed by MSOE with the help of Johnson Controls, where they can view the real-time electrical consumption by floor. The second tier of this program incorporates Energy Star's Commercial Buildings course into the university's Architectural Engineering and Construction Management curriculum. After issuing a memo to the AECM faculty, Dr. Outcall, Professor Wentz, and Dr. Wu responded favorably and will be implementing facets of the Energy Star's Commercial Buildings course into their curriculums.
We would like to thank our client, MSOE, for their willingness to work with 3 Milwaukee NECA contractors. These include Venture Electric for building automation, Staff Electric for renewable energies, and Pieper Power Clear Horizons for motor controls. We would also like to give a special thanks to NECA, the Milwaukee chapter of NECA, the American Transmission Company, Johnson Controls, and the Brewers for their generosity in helping to fund this Green Energy Challenge trip. On behalf of the Excel Electric team, I'd like to thank you for this opportunity to present to you today, and now would like to open up the floor to any questions.
Very nice job, you guys. Good job. I'd like to start out with a question around financing options. You put out a very good proposal about what the opportunities are, what the paybacks are, and the costs, but what are the options to the customer around financing?
First, we would tackle that problem by trying to procure all the government grants and rebates out there using such tools as DSIRE and our focus on energy and Milwaukee Shines. That'd be the first step to trying to lower the installation cost for the client. The second way we'd approach it is showing them the benefit of lowering energy consumption along with life cycle cost. The third option would be if they could not extend their credit out that far, then tap into our finances to finance potentially for them at an interest rate that is in line with today's prime.
I see that you got a very good reaction from your faculty, but what was the reaction for the rest of the school?
When we did the initial survey to the students, they were very excited about the opportunity to reduce the heat in the dorm rooms. I believe most of them sleep without blankets in the winter, so it would be pretty beneficial from a student standpoint, as well as being an engineering school, we're all really aware of energy consumption and sustainability. So from a sustainability standpoint, I think everyone's really on board with trying to make the campus more sustainable. So from a student standpoint, we're really into the program. And from other faculty around in our mechanical engineering department, they are actually the ones who designed the reheat system that's on top of the other dormitory. So there are a lot of other areas around campus where sustainability is already in action. So we're just trying to build on what they already have.
But I mean, this awareness that you created, are they sure that it's just a group of guys, or is it something related to NECA's student chapter? I mean, do you have accreditation as a NECA student chapter?
We are one of several architectural engineering student chapters. We work collectively with Venture Electric, President Jeff Robertson, to get the Metasys system actually installed in a dormitory this year to actually do the energy conservation competition. So not only are we have approximately 20 members, but we also reach out to the NECA contractors such as Venture, Peeper, and staff to kind of to show students that it's not only in a college world, it's actually the real world that needs to get involved in this and help us out.
If the owner wanted to move the project out 6 months, do you see any impacts?
Actually, there probably would be more of an impact. We designed the schedule to be more during the summer, just for the simple fact that there's less students, less interference. The main reason why we broke it into 4 phases was because during the summer, MSOE still does house college students and high school students, but it's not as full. So we were able to talk to MSOE, and they said that yes, 3 floors at a time would be possible, and we would allow the weekend for the students to move into the new dorms that are completed.
Quick question for you. This kind of goes off the map on the proposal you guys just gave. Has your facility manager seen this? At
Yes,
the university?
we were actually working collectively with the engineering facility people. They were the initial ones that came into our Green Energy Challenge meetings to let us know what updates were needed. Not only that, they listened to our ideas and actually did move forward with updating the lighting in RWJ with a NECA contractor this summer.
You thanked your local NECA chapter for their assistance. Can you go into some detail on how that interaction happened and how you worked with the local NECA chapter to put together such a good proposal?
I myself was an electrician for 11 years, so I had some contacts with Staff Electric. I contacted Bob Raybert. He turned me on to Venture Electric and Peeper Electric, and we moved from there. We identified that Peeper was good at motor controls, therefore we sought out Leo Manny. Jeff Robertson for the building automation system, working collectively with Johnson Controls, whom he does a lot of accounts with. And for myself, working for Staff Electric for 11 years, I was able to find the right resources for the renewables.
Thank you very much. Those were terrific presentations. I appreciate the work. Before we leave, there's some special people that I just want to mention here because the foundation budgets a certain amount of awards here for for these, all these students. But we've got three individuals and companies that really help us, and they add to the awards, and this is like the third year in a row for Tim McBride at Southern Contracting. Let's give him a hand. And Walter Parks at O'Connell Electric in Victor, New York, and he's back in there. And also Diane Fortier from Pearson Learning Solutions. So they're here too. Thank you. There's right across the hall. The one thing about the students attending the convention here, they actually get to work here too. So they participate in helping us out with the meeting, and also get to interact with all of you. So the students have to go to room 2 across the hall, and they're going to have an orientation meeting over there, starting as soon as we finish here. Okay, that's it. The judges have to total up their proposals here, or their scores here, and Beta will work with them. There's one last person I want to mention, and that's Beta Silverman. She manages this pretty much single-handedly, and she works all through the year with all these schools, and she gets calls on nights and weekends, probably when the students are out in a group drinking in their local pub on the weekend. They get some ideas for their proposals, and they call her, and she has conference calls with the faculty and everything. So thank you, Beta, very much. And we'll announce the winners at where are they announced? At the final session, the closing session. Tomorrow it's announced? Oh, at the Electric Council meeting. Okay. We'll do it at both. Thank you very much.